Okay, question 6. Work out the next term of this quadratic sequence. So if we look at the terms, we can see 4 to 12 goes up by 8, then it goes up by 12, then it goes up by 16, okay? And because they're not going up by the same number, that's why this is a quadratic. So if they were going up by the same number, so plus 8, plus 8, plus 8, then that would be a linear sequence. This one is quadratic. So following the pattern, so add 12, so add 8, add 12, add 16. The next one is going to be add 20, means that the next term would be 60. Now, when I was doing this in class, some of my students were trying to work out the nth term of this quadratic sequence. They thought the question was a lot harder than this. So as a quick recap, I'm going to go into now talk about how to find the nth term of this quadratic sequence, but obviously you don't need to do that for this question. It's just a bit of revision. Okay, so if I wanted to find the nth term of this sequence, I would need to, because they're not going up by the same amount each time, I would need to find what's called the second difference. So I'm going to need to find the difference of these differences. So I've got plus 8 to plus 12, so that's plus 4. 12 to 16 is also plus 4, and that is also plus 4. And this is what I'm looking for, because I've now got the second difference, which are all the same term. This tells me it's quadratic. Okay, there are some sequences where the third difference, so these would be different as well, and the third difference would be all the same, and that gives you a cubic nth term, but you won't need to know that for GCSE. So we've come up to this stage. To find the nth term, what I need to do is half the second difference. So half of 4 is 2, so that means my nth term would be 2n squared. Okay, so we know it's going to be n squared because it's quadratic, and the number in front is always half this value here. So if this was a 5, then it would be 2.5 n squared, and so on. Okay, now if we could just consider what sequence this produces. So if I put in values for n, so the first number of the sequence, n, would be 1. So I need to square it first and then times it by 2. Because of BIDMAS, we always do the indices before we multiply it. So 1 squared is 1, times 2 is 2. So the first number of this sequence would be 2. The next number, so n would be 2. So I'm doing 2 squared, which gives me 4. And 4 times 2 is 8. Okay. Notice if I did it the other way around, if I did 2 times 2, which is 4, and then squared it, I get 16. So you get the complete wrong answer. So that's why you have to do the indices first before you multiply it. The third number of the sequence, n, is 3. So 3 squared is 9, times 2 is 18. And we'll do one more. The fourth term in the sequence, 4 squared is 16, then times it by 2, gives you 32. Now if we compare what we've just generated with what we actually need, we're not quite there yet. So far, the nth term that we've come up with only generates these numbers, but we don't want 2, we want 4. So I need to actually add on another 2. We don't want 8, we want 12, so I need to add on another 4 to this term. I don't want 18, I want 24, so I need to add on another 6 to this term. And I don't want 32, I want 40, so I need to add on another 8 to this term. Now, we can see here that the numbers aren't going up by the same amount. If they were going up by the same amount, say it was plus 2, plus 2, plus 2, plus 2, my nth term would be 2n squared plus 2. But because they're not going up by the same amount, I need to actually find the nth term of this sequence. Okay. Remember, it's not very complicated if it's just linear. So this is all going up by 2's. And if it's linear, then you just put that number in front of n. So I get 2n. And then you find the number before the first number in the sequence. So the first number of this little sequence here was 2. The number before it would be 0. So it would be 2n plus 0, which we don't need to write down. So that is the nth term of these differences here. So putting this together, I know it's 2n squared, that gives me this bit, and I need to add, because I want the numbers to be bigger, 2n. So if I wanted to work out the nth term of this quadratic sequence, which, like I said before, you don't need to do that for this particular question, but it's good revision. Putting them together, I get 2n squared plus 2m.